In this question, we're trying to find the normal force that acts on a 900 kilogram car while it's being lowered in a garage with an acceleration of 1.2 meters per second squared. So it's being lowered with 1.2 meters per second squared worth of acceleration, and we're trying to find the squeeze, which is known as the normal force, between the wheels and the lift. So once again, we start this question with a simplified free body diagram. So here's my 900 kilogram car. What forces are acting on it directly? Certainly gravity straight down, pulling it towards the center of the earth. And then the car is being held up by this hoist, so there's a normal force that's upwards. Now, since the car is accelerating down, that normal force must be losing. Gravity must be a larger force to cause the car to accelerate down. Now, those are the only two forces that are acting on it, and those two forces combine to make a net force, always in the direction of your acceleration, that's down. So there's step one. We've drawn our free body diagram and we've identified the direction of the net force. Step two is our definition of the net force. The unbalanced force or net force is simply the sum of all the forces that are acting on that object. Now, I'm defining the net force down, so I'm going to say the winning forces, the ones that we're calling positive, are going to be down as well. So F net is down, Fg must be winning, and we're going to subtract the losing forces, the ones that are going in the opposite direction, which is my normal force, which is what we're trying to figure out. Now we're trying to solve it for Fn, so let's get Fn by itself by adding an Fn first to both sides. So I get F net plus Fn equals Fg. Now to get rid of the F net, I subtract an F net from both sides, and I end up with F normal is Fg minus F net. So that's what I'm trying to solve. Now we have equations for Fg and equations for F net, so it shouldn't be a problem finishing off the question. Okay, Fg is mass times gravity, F net is ma, and we simply plug in our numbers. 900 times 9.8 minus 900 times my acceleration, which is 1.2. And again, don't put negative 9.8 in. You've already defined all the signs at this step right here. So when we crank that out, we end up getting normal force of 7,700 newtons.